This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi, this is Jeremy Jung for Software Engineering Radio, and today I'm talking to Jonathan Horvath. He's the owner of the Z-bit Physical Access Control Systems Consultancy and the author of an open source implementation of the Open Supervised Device Protocol. He has over 25 years of experience in the physical access control system space, and he got his start answering support calls at Linnell Systems. Jonathan, welcome to Software Engineering Radio.
Hello, Jeremy. Glad to be here.
I think a lot of our audience, they may have interacted with physical access control systems, but they probably don't actually know what that means. So could you start by explaining what that means?
So physical access control is monitoring and giving access to and securing physical spaces. If you compare it to a logical access control with identity management, it does a lot of the same things, but it's in the physical domain. So you have a lot of the same concepts. You have authentication, authorization, and audit. So when you go up to a secure area, you want to authenticate yourself, typically with a card, or nowadays a lot of people use mobile phones or even biometrics like a fingerprint. And then there's a check to see if you're authorized to enter that space. And like I said, it's typically through a door, but there's other ways of accessing a physical space. And then once you've been authorized, then you audit, or if you're not authorized, it'll audit that transaction. Physical access control also encompasses other security monitoring and aspects to those physical spaces. So a lot of physical access control software systems will include like video surveillance, contacts. If you have an analog contact that's connected to a window and someone opens the window, you might want to monitor that. And control points, some that you would regularly use a control point for is to unlock a door strike. So to manage and to effectively secure those spaces, that's all in the realm of physical access control.
And so you talked about authentication and authorization. So authentication is determining who you are, and that's based off of the token. Like you said, it could be a card or a mobile phone. And then the authorization, that's deciding whether or not you're supposed to be able to get into that door or that vehicle turnstile, that place you're trying to enter. Is that right?
Yes, correct.
And you mentioned, I believe, did you say control point? Could you explain what you meant by that?
It deals with everything within the physical space that you need to secure. So there's times when you need to perform an action, or a lot of times the control points are relays. And like I said, a typical one is to unlock a door. There's a door strike, electronic door strike, and it's magnetized, and you need to provide control of that door when someone's authorized to enter that door. And other examples could be a gate to go into a parking space. And there's many other things you want to control depending on the situation you need to perform an action on.
So the control point in the example of, for example, a vehicle gate that somebody drives their car up to, they scan their card to get in to the parking lot, and the control point would be the physical thing that you need to control to cause the gate arm to open or something like that.
Exactly.
You kind of gave some examples of ways people might see this in their day-to-day. They might see it in entering their hotel room or entering their office building, going into a parking lot, things like that. What are the physical components of that system? Like there must be something to read the credential. There must be some kind of software piece in the background. Maybe you can walk us through.
So building up through the layers or the flow, it starts off with identifying who you are. So a lot of times, or it typically has been a card. So you carry everybody who, when you start at a company, one of the first things you get is the company card, and that gives you access to the door. At a hotel room, one of the first things you get is your hotel key, and you get into your hotel room. If you are signed up for a parking garage downtown in some city, when you pay your monthly due, the first thing you get is a parking garage card. So that's the typical way of gaining access. This has been changing in the past 10 or 15 years with the introduction of biometrics. So now people with higher secured areas, there's fingerprint. More traditional, now I'm thinking about it, is, a keypad. Some places that instead of giving out cards, they give you a PIN code and you use that PIN code. And that's something not necessarily something you have. There's multi-factor authentication like in the logical access control. So you might use a combination of a card and a fingerprint or a card and PIN for higher secured areas. And then the next part is the actual reader who takes that card, PIN, keypad, biometrics, and it's the physical interface between the person and the physical access control software system. Those readers, and we'll get into it later, we can have a discussion, but those readers is the endpoint in the system. So a lot of times those readers just pass through the information, but with the chips becoming cheaper and more economical to actually do some decision making and have some intelligence at that reader. And then once the reader collects that information, either be a PIN, card number, biometric, fingerprint template, it transmits that to a panel. So it's an access control panel that's usually in a lock cabinet that's secured. So it doesn't go right to the server or host. These are life safety systems, so a lot of required to have a separate panel that's been hardened, and that usually has like a backup, like a local battery hooked up to it, so that if there's a power outage, it can still continue to allow people to enter and exit physical spaces. And it has a 12-volt, looks like a little car battery, maybe like a quarter of the size, but it sits there, and the panel is just what you would like a fire panel or any other. It's just basically, it looks like a motherboard, and it has a bunch of inputs and outputs, relays, and some COM ports that hooks up to your readers and other downstream panels. One panel might manage like 128 doors, and they have sub panels hooked up for all those doors. They don't go into one panel. They daisy chain them down with sub panels for readers and other IOs. And then that hooks up to a host system. So you have all these panels within your physical access control system. You have a large enterprise, you might have thousands of those panels, and they all have to be managed and updated with new credentials, new access levels, new time zones, different actions or workflows depending on various inputs or events that happen. And this is where I'm mostly involved with, is the actual development of that software that runs on a server, and the adoption has been increasing like on the cloud that manages all these panels. So that gives you kind of a high-level architectural overview of when you're looking at a physical access control system. Like I said, there's 4 components. You have the credential, the physical credential, and like I said, that credential could be a fingerprint or a biometrics, and then you have the reader, the endpoint, the panel, and that panel typically is the one that making the decision whether you're authorized or not. It has a full database. If it's disconnected from the host system, it can make all the decisions locally on premise. And then you have the host software that manages all the panels within your system.
So if I break it down a little bit, the person, let's say they go to their office building, there's a card reader on the outside, they present their credential. You had mentioned that the card reader is almost like a pass-through kind of thing. It gets the card number or the information identifying you from the card. It sends that to the panel. And then the panel, you said, has its own local database that decides whether or not you get into the building. And if it decides that you do, that panel is physically wired to what you were referring to as control points. So the door strike that unlocks the door, the panel is connected to that. And so it'll make the decision to let you in and take care of that.
Mm-hmm.
That last part you mentioned, the server software or the software that's connecting to these panels, I'm guessing that's updating these panels' databases. That's sort of the source of truth in terms of who's supposed to get in and who's not.
Yeah, that is the source of truth. That is the interaction from the operators of the system is through that host system. That host system, in our industry, Windows is pretty prevalent. So on a Windows server, some of the software I work with is old school client server. So you still have like WinForms or other traditional Windows UI elements, or it could be a web-based UI, and that makes the update. So you enroll if a new employee comes in, you go to a badging station and you take a photo and you store that in the host system and you type in their first and last name, maybe some other identifying information, and you issue them a card, and that card is associated with that new employee. Or you go into the host system and say, I want to give this person to all employee doors. And those employee doors, if it's a large campus, might be connected to many panels. So the software host system needs to decide where this information needs to be set and what information needs to be set. And it figures out through drivers. Jonathan Horvath is starting at company Acme. His credential needs to go down, and then this credential specifically will have access to these doors. And there's time zones involved to scheduling. So maybe he has access to these doors during business hours, certain doors, maybe other doors he has access all hours, depending on the security of those areas. And other doors, obviously, they're not associated with, so I'll get denied access to maybe that super secret government section of the building where only certain employees could go in, or the executive suite or something of that nature.
And so when you mentioned the drivers, that would be the software that the server software needs to know how to communicate with the panels?
Correct. It's typically called a driver. I could give you a little further background. When I first started, access control systems were proprietary, and they were all those components that we talked about earlier were developed and sold as one system. So you would have a card, you would have a reader, you would have an access panel, and you would have, way back, would actually go right to the control panel and program that, but that doesn't scale as these systems became larger. And you would create a custom protocol between the panel and the host system. And actually, to this day, a lot of that is proprietary. So each panel has their own protocol, or some of the newer ones have a REST API, and you would have to interface with that. So you would send down, as the information was entered into the host system would determine with each panel what data records need to go down to that panel, and it would update that panel with the appropriate credentials, the appropriate access levels, appropriate schedules, and you could do other local things there. Like if at certain times at night, it would lock the door. Maybe if it's a main entrance, it would unlock the door during business hours and lock. So you would have some decision making done at that panel. And as we progress, and some of the newer access control systems no longer is a single source for all those components. The software system might talk to different panels with different protocols. So that driver, even in the same system, so there might be 2 or 3 manufactured panels in there, and each one has to have a separate driver, much like a computer. So even though I'm doing the same function, each one has some nuance, and you have to translate your intended actions for each one to that particular manufacturer. More and more, these components are no longer a unified single source from one manufacturer. Now you have a lot of diversity. And you have to take an account of having different cards from different manufacturers, readers from another manufacturer, a panel from yet another manufacturer, and our whole system, software system from yet another manufacturer. And this has become more and more common. And this is one of the challenges in the physical access control currently, which is interesting because this is something that's been solved for many years within the IT and software development of having standard protocols. But this is something actually that's fairly new in these components we've been talking about within the physical access control space, which is great for someone who's been developing software in this industry for a long time, to kind of losing my hair over many years trying to have to deal with these proprietary systems and very limited what you could do creating solutions because of the proprietary implementations. Now that it's opening up to standards and open protocols, this is really has made my ability to provide solutions to my clients much easier.
The part that is proprietary or not standardized, it sounds like, is the panels, right?
My main pain point right now is the proprietary drivers that we were talking about between the host system and the panel. That's still very proprietary. There is one open standard, but it's not really followed right now. There hasn't been really a market push to open that up. But we'll get into some of my other areas that have the other links between the other lower level communication. Those have become standardized. So I'm hoping once those become more mature, we can work back up to where I spend most of my time with the software development of the host system.
And so since there isn't a standard way of communicating between the host system and the panels, do you see any kind of common ways that they build these interfaces? Is it usually some kind of proprietary TCP interface, or are they using HTTP? I'm just curious what those typically look like.
So there's common terms, you have credential, you have access level, you have time zone or schedule. So you have some common domain terms, but it's all over the place. Everyone is really a snowflake and unique, and it's how it implements. Some have raw TCP, very archaic commands that are a bunch of numbers, and you look at it, you have no idea. If you didn't have the API guide, it just is a series of numbers, maybe with some text in there. And then there's all the way up to a nice REST API, a little more modern REST API, and everything in between. But yeah, it's all over the board what you will encounter.
It sounds like when you were mentioning needing the documentation and things like this, is this the sort of thing where you can't really integrate with these panels unless you have support from these vendors?
Yeah, correct. So because it's proprietary, a lot of times you don't have public access to a lot of these APIs. So you have to either sign an agreement, and it's very restricted. So a lot of times I will work through a client, and the client has access to it, and because I'm working through them, I'll have access to it. But I have to be very careful I can't share it with anyone. It's a very closed system. And for the project I'm working on, it's fine, and you can get support. But if you want to go beyond that, or if you think of ideas of, I got this panel and I want to add this new functionality to it, there are some roadblocks to doing that. A lot of times you have to go through the manufacturer and get their blessing. A lot of traditional web-based services, you have a great idea and you go build it, and, have all these open protocols like HTML and JavaScript, and use WordPress or, whatever great frameworks, React or whatever are out there, and you build your great idea. When I work in my domain, everything's limited because whatever you do needs to be expressed in some physical form. So you have these gatekeepers of manufacturers who build these physical products that you need to interact with, be it the panel, reader, or credentials. And if they don't give the blessing, even though you have this great idea, you can't really go anywhere with it. You have to work with that, which makes it tough sometimes, but it makes it interesting. I mean, I really do enjoy the aspect of building something and having the physical manifestation of what you've done. In my office here, I have all kinds of readers and devices and stuff. And it gets me excited when I program something and I see it physically work the way I'm supposed to work right next to me. And then, you go into buildings and stuff and you see how all these devices work, and you have an impact on making sure they're working properly.
It sounds like when you think about, for example, IoT devices, there are standards or message formats like MQTT, or if you are working with cameras, it's pretty common for there to be an RTSP stream, so a standard way of streaming the video, a standard codec. But on the physical access control side, it sounds like there really isn't that kind of ecosystem.
Yeah, no, isn't really. I mean, I went off on my own and did my own consulting business. That's one of the main passions and drivers I had moving forward, is try to introduce some open standards. So a lot of my work is building solutions that are based off of open standards. And there is a movement within the industry to embrace these new standards. In my opinion, it's one of those evolutions of the industry that will help grow the market. So it's pretty exciting now to be involved with these various open standard work groups and conferences and see that the industry is finally embracing these. It does take a while, though. Unlike traditional software engineering, even if we had all the standards mapped out and everybody agreed to them, there is a long cycle time to implement them because we're talking about physical hardware. So it's not, we got a new update to the standard or we want to implement the standard. You can't just push a button and do your automated builds and automated deployments and deploy it to your host system. You need to have all the hardware in place. And those hardwares need to be updated. So you might have to go and, if they're older hardware, you might have to replace them. If you have newer hardware that may need to have an updated firmware. So you might have, depending on the firmware version, you might actually have to physically go and connect to the reader and update the firmware on them to support this new standard. Same thing with the panels. A lot of the panels, you can do firmware updates, luckily now, but you still have to push those out, and you have to coordinate with your security operations center because you have downtime. So there's a lot of things you got to take into consideration that may not, in a pure virtual logical world, you don't need to take account for. And even the credentials, I was in a conference earlier this week where we're looking to standardize on the credential protocols between the credential and the reader. And, that's for a large company or even a small one with limited resources, it's a big undertaking to replace all those credentials, or, you can't just rebadge everybody, especially these days where everybody's not coming to the office. Being able to get badges to everybody is a big undertaking, and the cost of just the badges and having employees go to, making sure the badges get securely to the employees. You can't just, maybe you probably don't want to mail them out. There's a lot of logistical overhead on deploying a new standard. So there's a lot more considerations that need to be taken into account. If you update to a new badge technology, a lot of times you have to, what they call a bridge. If you have 1,000 readers, which is a moderately sized system, you'll have some readers that have the new technology or the new standard, and you have some that don't. But people don't want to carry 3 or 4 badges for all these different, and knowing which badge to use at what reader. So you have badges with multiple technologies on them. You have readers that can read multiple technologies, and you have panels that can interpret those multiple technologies. So you have these backward compatibilities with this rollout that could take a few years as you replace the hardware or update the firmware or enter new card formats. So yeah, there's a lot of thought and consideration needs to be have for rolling out new technologies and new standards.
So I thought we could kind of walk through a little bit deeper into each of the components. One of the things you mentioned is the host software or the server software that's talking to the panels, and how it was typically a Windows application. I was wondering if you had any insight into why that was.
So actually, the company you mentioned in my bio, Linnell Systems, probably had a lot to do with that. So when I started out in access control, it wasn't like I was growing up and say I wanted to do physical access control. I liked computers and hacked around and played with the old PCs and did some Linux, Unix stuff when I was in college. And I was looking for a job, and just so happened a physical access control startup named Linnell Systems was not too far from me, a few miles away, and got a job there. And it was one of the first access control systems. Before Linnell, most of them, like I said, you would either program directly on the panel. You would hook up a computer using a serial COM port, if you remember the old serial. And we still use those a lot in our industry. But you'd have the old serial port on your computer, and you would hook it up there, and you would type in some archaic commands, and you would do it manually. And then in the 80s and 90s, you would have Unix base, but they were very expensive. You would have to have a expensive Unix computer, and they were still command line, mostly done through command line, and they were clunky, and you kind of had to have like a access control guru to go in there. And Linnell Systems, they one of the first companies, and they became very popular and spearheaded this to support a graphical interface. And one of the first big customers of Linnell was Microsoft, and they started early on betting the company on the popularity of Windows NT, the precursor to your modern Windows system. And they became very successful. They come to become one of the top physical access control companies within the industry a few years later. So that kind of drove the adoption of Windows as a physical access control system for hosts. And like I said, once a company gets established within the industry, it's very hard to replace them because of the hardware consideration that I was talking about earlier. So that was the first widely deployed access control system that was very user-friendly, was through Windows in the late 90s and early 2000s. And it was mostly on-premise too, because a lot of times, especially early on, they were on a separate network. There was no internet access. This is a secure system. And to ensure no outside access, a lot of times these systems didn't have any internet access. So internet, even though the Linnell systems started out in the .com area where a lot of stuff was going online and on the web, a lot of the customers didn't want their physical access control system online. So a lot of it was all of it was on-premise until the past 10 years or so. So Windows made the most sense. It was the most economical way of deploying an on-premise system. So that's a quick background. Now there's a lot more diversity. You have cloud-based systems, I'm sure, written in various languages. You have Linux that are typically black boxes. So you buy a host system that's basically, a box, and you put it in and you can mount it in your server room, and there's just a web interface. So there's some of those that have come up over the years, but just the momentum of when the Windows systems became popular in the early 2000s, we're still riding that momentum, and slowly they're being replaced. But like I said, it's a common theme. These technologies are hard to replace once they get embedded. They have a shelf life of 10, 20 years.
Yeah, so it seems like more of a result of when this industry started, because I do recall that, late 90s, early 2000s, a lot of people were still running server software on Windows. And it seems like the last 10, 15 years, there's been this shift to where the majority is probably on Linux now. So maybe if this industry had really come up later, then maybe it wouldn't have been Windows.
Yeah, exactly. It's just the timing. Ideally, with these open standards that I've been promoting and advocating for, it'll be easier to keep up with technology as it comes out. That would be the hope, and that's one of the sales pitches that I commonly give to clients. Once these physical access control systems started to connect to the network and the internet, taking your time to update stuff and kind of resting on your laurels as far as doing security patches and all that, it was kind of a comfort, and it didn't seem to be as important to keep up with stuff because, we're on a separate network. There's no outside access. So you still do updates and everything, but since we're not connected to anything, there was kind of a security blanket, that we didn't need to be concerned so much about interconnectivity and standards and all that. And that has changed. Most of these systems are now being connected to their corporate network. And even now with the cloud-based systems are connected to the internet. So standards are becoming more and more important as part of the whole physical access control system, because it's no longer an isolated system. It is part of a larger enterprise system or a larger interconnected online system. So that's forcing, and IT obviously is more involved now because it's part of their IT system. So they demand like what's going on underneath the hood. What protocols are you using? Can we interface with those? How do we interface with those? So hiding behind the curtain is no longer acceptable for new deployments, and existing deployments are being reviewed and questioned to why these legacy systems still have these restrictions.
Yeah, that makes sense. Like you were saying before, it didn't matter as much because you figure, somebody has to physically be here and connect to our network.
These cabinets are locked and these host systems are disconnected from the rest of the network. There was a sense that some of these security shortcomings were okay because, as long as there's no outside access. I was thinking as you were talking, I remember watching a movie and there was a heist going on, an actual site of where I programmed the access control system. And I was so worried, like they were looking to figure out how to get in there. And, they were talking about the security system and how they're going to circumvent it. And I was so worried that they were going to hack it, like the traditional hack where, you go in and you find a vulnerability in the security system. And I was actually, I felt it within my gut. Like I was nervous about this, it's make believe it's a movie. It has nothing to do, but it seemed kind of personal to me because they were trying to get into a security system that I was involved with building. And what you were saying earlier, what they ended up doing was they got one of the guards and they compromised him. I don't know, took him to a strip club or something and took his badge and used his badge to actually get into the data center. And they put a little bugger on there and they had physical access into the physical system, into the physical access control system or whatever, and the video system. So once they put the little thing on the network cable, and then they had access to everything because they were physically inside the building, inside the server room. And I breathed a sigh of relief, like, they didn't hack my system. They actually physically went in, and there's nothing you can do at that point. So once you physically get into the data center or to the server, there's not much you can do. It's, if you're not detected and you're in there, you can put sniffers on there and you can do all kinds of stuff that, once you have physical access to something, all bets are off.
You had mentioned that there are a lot of vulnerabilities that continue to exist. I wonder if you can talk about some of those.
The most interesting one, brings up the conference I was in earlier this week. So credentials continually have issues of being able to clone them or replicate them. It's been an ongoing issue for as long as I can remember. Credentials started with mag stripes. It was one of the first things that replaced. Essentially we're replacing lock and key on doors. And the mag stripe, and I'm assuming most people are familiar with it. It's kind of dated these days, but even new credit cards still have that mag stripe on the back. And then the mag stripe essentially is an encoded bytes. I'm really dating myself. When I started with computers, we used to store our programs on cassette tapes, and it's the same concept. Obviously, those are easy to clone. You can take that mag stripe, and when you present it to a reader in the old days, it would just take those bytes and transmit them to the panel. If I got a hold of your badge, I could take that mag stripe and swipe it into my own reader and get those bytes, and then create a new mag stripe with the same exact bytes like you were, like I said, I'm dating myself, but the old cassette tape, you could take a cassette tape and put it in one of those dual copiers, and you could put another cassette tape there and you could make a copy of it. So it was really easy to clone. And mag stripes they got replaced by a thing called Prox. That's the contactless card that everybody's familiar with, where you tap the card on the reader. So the initial Prox were, you looking back and they were very insecure. So basically it took those mag stripe bytes and you put them in a magnetic ring of wires. And when you present it to a reader, it would energize them and it would send out a unique bit array and send that from the reader up to the panel through unencrypted one-way wires. So that was called Wiegand, and completely unencrypted. In the old days, it was kind of hard to clone those. You would need to have a lot of expensive equipment. It was just clunky. Nowadays, as things got smaller, to clone them is super easy. Because they're contactless. In some ways, the mag card is a little more secure because you actually have to physically take the card and swipe it. The contactless, you could walk up to someone, and if you have the right equipment, you can be like within a few feet and you can capture that card and energize it and get the bit array, and then you can create your own card and you can be that person. So that's Wiegand. And to this day, there's still deployments with Wiegand going out. And there's obviously exists, like I said, this stuff has shelf life of decades. So there's still systems out there using this fairly easy to clone, not very secure card. And the past 15 or so years, there's smart cards. Typically, the chip on the card, a lot of the credit cards have, and they have keys and they encrypt and decrypt the communications between the card and the reader. And it's similar to credit cards. You can do contactless, you can do the tap, or you can put the card in and it'll make contact to the chip. And the initial implementation of those we're finding they have some significant security issues. The initial ones, you have to remember, these readers initially were pass-through devices, so they were very cheap to produce. They weren't really doing anything. They were just taken, in the Wiegand days, they were just basically taking the same transmission between the card and the reader and just continuing up to the panel. There was no protocol. It was just basically extending the reach of the panel to receive the credential and the Wiegand information from the card. There was no back and forth. The smart card, they didn't want to put a lot of new smarts into these readers because there was an expectation that these were still going to be cheap. So what they did is they did a shared key, a symmetrical key between the card and the reader. So you'd have a shared private key, which was better than Wiegand. You had two-way communication between the card and the reader, and it was encrypted. It was hard to clone. You couldn't clone it unless you had the actual private key. The problem, and they just did a presentation at DEF CON a few days ago, is that if someone figures out or are able to get that shared key, they can easily clone a card, because once you have the shared key, you can decrypt that card. And if you know about it, like I said earlier, it's hard to do updates. You would have to replace all the cards and update all the readers with a new key to mitigate that security issue. So that becomes very expensive. So what we're looking at, what's being attempted to do now, and this, like I said, requires readers to be updated with much more smarts than they've been traditionally been manufactured to have, is do asymmetrical keys, PKI, similar to like an SSH login. You would have a private key stored in a secure element, either within the smart card or mobile phone. And that's not shared. It's unique for every credential holder, every credential. And then that credential is validated using the public key that's transmitted in
if a hacker somehow figured out the private key on the card, they would just have access to that one card. It really minimizes your potential security risk to just that card instead of the whole system. So that's kind of the next, and this is what I've been involved with is, I don't know if you want to get into, but this has already been implemented in the government. Obviously, there's a lot of very secure government facilities. There's other proprietary solutions that were for commercial, but in the government, there's a identification regulation standard called PIV, personal identification, that is widespread through all the government agencies. And that's based on what I was just talking about, a PKI infrastructure with stored private key on the credential. So it's a very good way of thinking where the physical access industry needs to go. And we would have done that years ago, but we have all this hardware we need to replace. I mean, it's one of those obvious things. If you're doing software development or an IT person, technician or administrator, but I think a lot of people in our industry realize this, but I'm glad we talked about that earlier. You have to appreciate the amount of resources that are needed and the time needed to do the switch over. But it's good to see there's progress being made. And on the flip side too, there's some areas where you got to secure this area and you need to do PKI or PIV and, a government installation that has top secret information or sensitive. But there's other areas where it's not as important, that pretty good security, that it's not dead simple to get in, And another thing that's changed is the ability to, like I said, the old Wiegand stuff at first seemed kind of secure because the equipment to do the cloning was very expensive and very cumbersome. Like you would know if someone was walking up next to you because they would probably have a big, backpack with a bunch of devices. Like it would stand out. But there's newer devices out now that you can put in your pocket and you can stand next to someone and be able to clone it. So as technology gets better, even these kind of half-baked solutions that were fairly secure become much less secure as the ability to clone them becomes much easier and much less technically know how to be able to pull it off. Now there's devices you can buy off of Amazon that can do a lot of things for cloning with a lot of the badges that are out there now.
Are there any specific things to look for? Like, let's say you check into your hotel. Is there an obvious way to tell, this is something that I could easily clone?
Yeah, there are. So there's a device called the Flipper, and basically it has a bunch of technology that I actually have on my desk right now, but it made it into a consumable product that allows you to hack into physical access control systems. And it has an NFC chip on it and Wiegand reader and some other interfaces. And yeah, I mean, if you had the Flipper and you put your hotel badge key to it, it could tell you if it's, has a technology on there that is easily cracked. And then I don't know what you could do when you find out. I mean, you already have a reservation at a hotel. You're kind of stuck with it. I mean, I don't get too far into the weeds with that stuff. I know there's people who go in, they have their Flipper and they go and check. But what can you really do at that moment? You already have a reservation to stay there that night. You're not going to go around to different hotels and find the one that actually has a secure badge. I guess it's good knowledge to have. But like I said, personally, I don't really get into nitpicking each individual implementation. I try to provide tools and advocate for open standards that are inherently secure so that they're available, and hopefully anybody who's concerned about security will be able to implement that in a cost-effective fashion.
Yeah, I suppose in that example, the assumption would be once you check out of your hotel, that card, probably the access gets revoked or changed, so you couldn't just go back a week later and go into the same room?
It depends. A lot of times they do reprogram those cards, but they might use the same identifier on the card depending on how they implement it. So the identifier card, the reader might just have one unique identifier. Like this reader, if your card presents this identifier, it'll give you access. So maybe they erase it when you bring it back, but then they'll just reprogram it with the same exact identifier when the next guest comes in. So if I have that, let's say room 301, and I figured out what that because those readers on those doors aren't uplinked to anything. So they only know how to allow access to one particular identifier. Well, traditionally, I mean, maybe there could be newer readers that can get updates, but the cheaper readers will only allow a certain card number to gain access. And I think all the front desk is doing is erasing that card
and then reprogram it for the other room with that identifier. So once you get a room, you're able to clone, like I said, room 301, that will always work. It's not like that lock's getting updated with a different identifier for each person coming in, each customer that's coming in, sleeping for that night.
Oh, interesting. So the reader itself knows that I'm reader 301, and as long as you give me a card that says it's for 301, it may just open. It may not be tied to, like you were saying, a panel or a back-end server system to even check.
Yeah, so one thing I didn't get into, so the check-in of authorization can be done at just about every part of this system. We talked about the 4 parts. It could be done on the credential. So there are credentials out there that, because smart cards, the newer ones, more expensive ones they have storage on them. So you could store all your access decision-making right on that card. And as you present, there's called mesh access control. So as you present, it gets updates on where people have access to which reader. So, and then also cell phones. A cell phone, if you present it to a door, it could go up to the cloud and make access decisions. And based on what door you present it to, it say, oh, you have access to the door. And then it will some secret key or some type of encrypted thing to the door to unlock it. So the authorization decision could be made at the credential, could be at the reader. So if the reader is not connected to a panel, and this is, when you brought up hotel rooms, this is typically the case, it's an offline reader. The reader doesn't have any wired connections. It's just on that door. There's no wire that goes to a panel. And because these are battery powered, typically, if they have Wi-Fi on them, they're not continually getting updates through Wi-Fi. Otherwise, those batteries will be sapped of their power pretty quickly. So ideally, a lot of times, if they're Wi-Fi, they might only communicate back to the host system or panel like once a day. There's some low frequency, lower powered ways of communicating that can allow real-time updates, but usually they're proprietary. But there's things like some of the home automation, like Zigbee, I think Matter, and that can go over wireless for low power. And I have Z-Wave locks at my house, so those can do real time. But still, you got to be careful on how much traffic you do, because if you're constantly updating, especially with a high traffic area, those batteries will get sapped pretty quickly. But the technology is getting better and better, so you can do more and more of those offline locks or locks that are wireless. And then majority of, especially traditional, is the reader is hooked up to the panel, and the panel does the authorization, has its own local database, and that should be locked in a locked cabinet that's in a secure room. So the host system typically does not and should not be making those decisions just because they're not as reliable. The closer you can do it to the actual location, the more secure it is. The more layers you go through, there's more points of security vulnerabilities. So usually if you're in a host system, you're going through multiple layers. And once the traffic is traversing through the internet or through a corporate network, there's more opportunity to intercept that and do some man-in-the-middle hacking or intercepting.
Yeah, and I suppose if the host system is more commonly getting moved to the cloud, if you were relying on that to make the decision to let somebody in, if, let's say, you are going into an office building and the internet is down, then it's like you can't get in the building, which seems not great.
It becomes a life safety issue, so you want to make that decision-making as close to the endpoint as possible, so that if you lose connectivity, you have an emergency, you want to try to find ways to make the access control system still operational and be able to make decisions regardless of what's going on outside of your immediate area.
So you mentioned you've done work with the host systems. So it sounds like we were talking about earlier how usually that's a Windows application, but I wonder if at a high level, does it look like a typical web application with a web server and a database and that sort of thing?
Yeah, it's very much like your typical software application. When I started, it was client server, but these days there's a lot more web-based systems I work with. But it's a typical, you got database, it's some services running in the background, and then you have a UI to do the configuration of the system and to monitor it.
In terms of the database, is that the typical relational database, like a SQL Server, a Postgres, that kind of thing?
Correct. Yeah. SQL Server is typically, I've seen Oracle for a while. I see less Oracle these days, but SQL Server, because it's Windows-based and Microsoft technologies. But yeah, there's some other open source
databases I've seen with Linux-based systems.
And so the main part that's unique, I suppose, would be the drivers you mentioned earlier, where the host system knows how to talk to the panels downstream.
Yes.
And it seems like that could be anything from vendor proprietary protocols to HTTP, just whatever the vendor chose when they made that hardware.
Yeah, it's a wide range. You never know what you're going to get. Each one's pretty unique. There is no overriding standard between host and panel. But there is recently, and I've been involved with the past few years, a pretty widely adopted standard that has replaced Wiegand between the panel and the reader, and that is OSDP. With OSDP, provides a true protocol. So with the Wiegand days, you would have separate wires for all the functionality. So you would have a buzzer wire. You would have a LED wire, and you'd have a different LED wire for different colors. It was very cumbersome. Since, like I said, there was no protocol involved with Wiegand. OSDP provides a encrypted protocol between the reader and the panel, and it's an open standard. I'm actually involved with validating that devices are properly implemented and can be compatible. So it's no longer, I have to buy this reader with this panel. You can buy any OSDP compliant reader and hook it up to your OSDP compliant panel, and they should operate, be able to plug and play them in like you would do with a USB device to your computer. You would plug it in and start communicating and being able to get card reads and make beeping sounds and flash lights when you grant access to green, things of that nature. And this is starting to become widely adopted. It's, like I said, it takes time because you have to replace devices. You can't just add the new standard to your software and push a button. You have to update all the hardware to do that. So one of the things I did, I think that helped to drive adoption, is I provided all the code through open source repositories. So it made it real easy for vendors to be able to do tests and implement the OSDP standard. They didn't have to rebuild everything from scratch. They had reference implementations. And I'm hoping that can be replicated throughout these different layers. So now we have the OSDP standard replacing Wiegand. I talked about earlier, there's some standards. Hopefully one of them will be widely adopted to provide communication between the credential and the reader that doesn't have the vulnerabilities that we've discussed earlier. It uses PKI. And the one I'm involved right now is called PKOC. It's a Public Key Open Credential that uses public key for authorization of the credential and doesn't share the private key. So those two areas are coming along really well. And then still the panel, between the panel and the host, that's still mostly proprietary. There is an open standard out there, but it hasn't been widely adopted, called OnViv. And OnViv, if you're involved with video surveillance, is a very popular standard. Any camera you buy, I don't think you can even buy a camera these days without OnViv support. So it allows cameras to be hooked up to any video management system and be able to recognize its capabilities and download video, typically through RTSP, pretty seamlessly. And they do have a profile for physical access control, but I do not believe anybody's really adopted it. So that's one of the things I'll probably be looking at in the near future to see, do we take the OnViv access control profile and create some open source implementations, and hopefully that'll drive some adoptions, or is there make sense to come up with a new open standard? But you kind of have to take these one at a time and hopefully get the full interoperable open platform available, that is truly secure. And since it's open, people are free to look at it, and if there's security vulnerabilities, in real time, be able to apply fixes and make comments on those standards. It's easy to say, our proprietary solution is secure when no one looks at it. It's easy to make that claim. The nice thing about open standards is everybody can look at it and comment and raise concerns if there is a fundamental security vulnerability with that approach.
Yeah, so that's interesting because it seems like you're involved in each section. You're involved with card to reader, which is that PKOC thing you mentioned, and then reader to panel, which is that OSDP standard. And then finally, you have the host system to panel, which there is that existing OnViv standard, but maybe that'll work out, maybe it won't. Sounds like. Yeah,
exactly. Yeah. And to have a fully secure system, open system, all three of those interconnects need to have the proper implementation. If any of those are not properly implemented and secure, the weakest link in your chain type situation, you could
introduce security vulnerabilities into your system.
And so if somebody were to take your OSDP library, it sounds like what they would be able to do is when somebody scans their card at the reader, they would be able to get that card number. They would be able to, like you were saying, trigger things or communicate back to the reader to tell it to show a green light because the access is granted or things like that.
Exactly.
Yeah.
So I actually regularly hook up readers directly to my PC using a USB to serial connector and hook the reader up, and I'm able to connect to it, query it to see who makes the reader. And it's a true protocol, so you can do all the typical protocol actions, and you poll it to make sure it's actually online. Surprisingly, the old Wiegand readers, you wouldn't know if it was offline until an employee would call the operations center and say, this reader's not working, and no one would know because it's just a one-way communication. With OSDP, it has the second letters S for supervise. You can actually supervise that connection to see if it's online. Not only if it's online, if someone's trying to tamper with it. So if for some reason there's an actual command to let you know if it was power cycled or if there was a tamper, or someone's trying to mess with the reader. So once you have a true protocol, there's a lot more you can do to secure and get and monitor that endpoint that wasn't available before. So once you have that connected to your computer, you can do a lot of things as far as diagnostics. You can update firmware. Anything you would do that you would hook up to the panel, you could do from your computer. I wrote my open source using .NET because most of my clients are using Windows anyway, so .NET seems. And I did all the commands and stuff, and I have a little test console. So if you're having, and I have other tools too based off of that. So if you're having a reader that just doesn't seem to be working with your panel, you can hook it up and run some diagnostic commands. You could do a packet trace, and you can actually figure out why it's not behaving as expected.
And does that extend out to you gave the example of the most secure credential you could use would be something that uses PKI, that has like a client cert and things like that. Would it be from your library? You can actually receive the client cert?
Yeah, so there's been updates to OSDP. One of the reasons I'm involved is that validation of the public key validation can be done either at the reader or the panel. If it's done at the panel, it needs a protocol to transmit the information, and there's some back and forth that needs to go. You need to get the public key, you need to send some validated data to the credential, and the credential with the private key will send back some data, and you can validate if it matches as expected. So to do that, you need something like OSDP. So that's why I'm involved, and I've added extensions to OSDP. The standard is still in draft, so I'm still in active development, but you could hook up the reader and present a PKOC credential and use the library to validate the public-private key pair on that credential. You can also do that validation on the reader, and the reader, if it has more intelligence on it, it could do the back and forth challenge response, and it will send back your standard old school Wiegand bit array data, but do it within an OSDP packets for backward compatibility. And because the panel might not be able to do there's no panels that can do PKOC right now natively, so you kind of revert back to the bit array from the Wiegand days and send that back to the panel. But it's in an encrypted OSDP packet, so it can't be easily intercepted or spoofed or cloned along the wire.
And I suppose it's been somewhat implied, but I think when we typically think of Internet of Things type things, we think of things that have an Ethernet port and connect to a switch. But I think typically these readers and maybe even some of the panels, a lot of them are using serial communication, right?
So yeah, there's a lot of discussion. So the serial is legacy stuff. It's hard to replace legacy stuff, and you have to work around those constraints. So when access control electronic access, physical access control took off, it was cost prohibitive to put a network port on these days, you can put an Ethernet port or a wireless chip and, it's dimes or dollars. But back then, it could be a significant cost. It could be basically doubling the reader price to put, these chips on. So when they first got deployed to a lot of these places, the easiest thing to do is just do a serial. And we're not talking about high traffic either. I mean, we're just talking, the common Wiegand is just 26 bits, a few bytes. So you don't need a high speed Ethernet port. The serial port does just fine. And then there's distance. Ethernet can, I think, go, if I'm
remember, and I haven't been doing IT work in a long time, but I think it's like 300 or 400 feet. If you have a panel in the middle of the building, that's not going to reach to your door. Your door is going to be maybe thousands of feet away, depending on how big the building is. If it's like a warehouse. Serial communications with the right cable and can use RS-485 can go thousands of feet, I think up to 4,000 feet. So that's an order of magnitude longer. So instead of putting access control panels all over your building, you could put a central one and run all your wires, low voltage wires everywhere. And it's much cheaper for those wires compared to Ethernet wires. It's just 2 pairs. It's half duplex, but just 2 wires and power, and you can set up your door. If you had Ethernet, you would have Ethernet cable and you'd have an Ethernet switch. You would have to get IT involved to allocate IP addresses. A lot more complexity. So the RS-485 serial communication is a much more economical, and it doesn't really, other than being able to access it from the internet, it doesn't really have too many downsides at this stage. But I would imagine things could change, and Ethernet might be something that will become more prevalent as we move forward. There were Ethernet readers out. I've seen Ethernet readers, but it never really took off. Like I said, if you're an installer, there's not much to gain by putting an Ethernet reader on for the type of traffic. And it just creates actually more complexity and more downtime because you have to, like I said, you have to hook it up to a switch. Depending on the installation, if it's a small business, they might have like a cheap switch they bought at Best Buy, and that thing might crap out every day and people can't get access to the building. So it's good to have everything kind of self-contained. There are benefits to keeping that self-contained and have better control over the system.
Yeah, I think that's one of the interesting things about physical access control is, I think, with a lot of software development, the physical locations of things is so abstracted out. Like most people don't think about, how long an Ethernet run do I need to have from one device to the other? It's just not something you even think about, but in this space, it actually matters. So that's...
Yeah, you can't really abstract out the hardware. It's there. You have to think about, every time I do software development and physical access control, the hardware is always in the back of your mind. And a lot of discussions I have with other software developers, sometimes, we want to do a certain way and our software development background says, well, this makes perfect sense. Is why aren't we doing this way? And then you kind of have to reflect and say, well, it doesn't work in a hardware environment with low cost endpoints. Like you kind of have to always take a step back and think about the impacts of the stuff you're developing, how that's going to be used in the real world. And sometimes it doesn't line up and you have to adjust and sometimes not do the most elegant solutions. And, sometimes I hate to use the word hack, but you have to find ways around that and be able to make the best of that situation when you're dealing with antiquated hardware. Or really, if you're a software developer that always strives for that perfect, code base where everything kind of works elegantly together, physical access control would probably drive you crazy because it's rarely you can do that because you're always got constraints. And I find that exciting because there's a certain amount of satisfaction where you know this is elegant solution to where you want to go and you have these constraints. It becomes, every time I get into a project, it's always a unique situation where you kind of have to work around these constraints and you figure out. And if you really feel like you did a good job, you're very close to that elegant solution. You really didn't compromise anything with your design. Everything you want to do is still there, but it still works well in the physical space. And I think that's something that I always strive for in my development efforts.
I think that's a good place to end it on, but is there anything else you wanted to mention?
No, I think we did a good run through of all of the aspects of software development within the physical access control industry. I really enjoyed this discussion. That was great.
If people want to learn more about your OSDP library or your consultancy, where should they look?
So I have a website. It's z-bitco.com. They can go there, and I have some links to some of my open source projects and some information about things I'm involved with. So that's a good place to start.
Jonathan, thank you so much for joining me on Software Engineering Radio.
Great. Great talking to you.
All right. This has been Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@sc-radio.net. This and all other episodes of SC Radio is licensed under Creative Commons License 2.5. Thanks for listening.